All right, we're going to solve the number of islands problem, which is going to be a great example of a depth-first search. We have a grid of m by n, so it doesn't necessarily have to be a square. And in this grid, we're going to have 1 represent land, so that's the island, and 0 is water. We want to find the number of islands. And the way that we define an island is that it's surrounded by water from all sides and connecting adjacent lengths horizontally and vertically. So we're looking horizontally for ones and we're looking vertically for ones. This is an example of an island. We have 4 across, then right next to it we have 2. Right here we have a little peninsula, so we can go down, but it's surrounded by water on 2 sides. So that's where the island ends. And then we have 2 more vertically, and everything else is water. So we really only have that one big island. In our second example, let's see what we have. We have 2 across, then it's water. Then we have 2 down. So that's island number 1. So all of this is water, all of this is water, all of this is water. Oh, we have this straggling one right here. So that's 2 islands. And it's surrounded by water, water, water. And finally, we have that 3rd island, also surrounded by water. Even though this is on a diagonal, we do not consider it part of the island. All right, easy enough. So how would we do this as a computer? Well, we start with the initial grid. I'm going to make a very simple grid right here. We have 1, 1, 1, so we should have 1 island. Step 1, we start exploring. So S marks the start of our exploration. And basically we have a for loop within a for loop. And we're going to hit each cell right here. So then we mark and move. So the first direction I'm going to go is to the right. And I'm going to mark it with a V, which means it has been visited. So we just exhausted the right direction because the next move we can make in the right direction is a 0. So now we start backtracking. We're back to the V. What other directions do we have left? Well, we can't go up because that's a boundary. We can't go down because that's water. So we got to backtrack again. And now we explore this. Can't go left. That's boundary. Up is a boundary. We already explored that right direction. So the only thing we can do is go down. All right, so we went down, visited it. It's land. Can we go to the right? We cannot. It's water. Can we go down? Nope, it's water. Can we go up? Well, we already visited that, and to the left is a boundary. So this is our final state. We have visited, visited, visited. Oh, right. So then we want to continue exploring. So we have our for loop grid, and we move on to our second cell. Well, this one is already visited, so we don't need to do the whole depth first search. How about this one? Well, this one is not land, so we don't have to explore that. This one's visited, not land, not land, not land, not land, not land, and I think we're done. So we only find 1 island. Let's try a more complex example. So this guy has 3 islands. We start out, it's visited. Can't go anywhere else. So what do? We continue going down the columns. So over here, 0, nope. Actually, how did we do this? Sorry, my bad. This should be visited. And this should be a 1. This would be visited, and this should be visited. Okay, I think that's correct. So we're scanning down the rows. Visited, we hit a 1, so that's visited. And again, we can't really go there. This row doesn't have anything. This row has the 1, so we mark that as visited. And that's it. We have our 3 visited islands. Yeah. So that is basically how we do it from a visual point of view. Now let's get to the code. So we start out with our counter for the number of islands, and now we go through our grid. So it's just a nested for loop, and we say, all right, is there land? If there's not land, then we just continue. If there is land, then we have to do that depth first search that we talked about. Basically going to the right, to the left, up, down, left, right, etc., etc. If there's land, we mark it as a island. And the thing is, we don't have to worry about marking an island twice because we are going to mark all the adjacent lands as visited. Essentially, if we land back on square with land, we already know that we hit it. How does the depth first search work? Well, the basic idea of a depth first search is we're going to give the conditions for to recurse in all of the different directions. If we want to explore up, then we need to decrement the row by 1. If we want to explore down, we increment it. If we want to go to the left, then the column is -1. If we want to go to the right, then it's column +1. But we also have a few conditions. And let me actually separate this out. So is water is this guy. And then is visited is this guy. Just to make it a little bit easier to read. So we have a few scenarios here. The first one is the row is greater or equal to the grid dot length. The grid dot length is the number of rows. That means we're out of bounds. Column is less than 0, so we went too far to the left. Column is greater than the row's length, so that means we went too far to the right. And we can't go too far up because we already started at 0, 0. So then the other disqualifying condition is if we hit water. If we hit water, that's it. We exhausted that direction. So over here we're exploring the up direction. We just exhausted the up direction because we hit water. The other condition is we already visited that square. We don't need to recurse through a cell that we already visited. All right, so all of this, if any of these conditions are met, then we return and it short circuits this recursion, meaning we go to the next recursion. So we just finished exploring up. Now we're going to explore down. We exhausted all the downs, we're gonna go to the left. We exhausted all the lefts, we're gonna go to the right. And finally, we exhausted everything. Well, if we exhausted everything, then we definitely will meet one of these conditions sooner or later. We'll hit the end of the row, or we'll hit the end of the number of rows, so in the vertical direction. And this right here, it marks that we visited that piece of land. Alrighty, so that is basically the explanation. Again, we start with the first cell. It's a 1, it's visited. We set the number of islands to 1. Then can we go down? We cannot go down. Can we go to the right? We cannot go to the right. Can we go up? Nope. Left? Nope. All right. And then we keep iterating. 0, so 0 is not land, meaning, is water, which means we return. We go on to the next cell. 0 is water, we return. 1, finally land. Can we go to the left? No. Can we go to the right? No. Up? No. Down? No. So we increment our land by 1, and then we scan this row, and then we scan this row. So hopefully this gives a more visual understanding of how that depth first search works. Remember, the first part of a depth first search is going to be iterating through that grid. The second part is going to identify, all right, what is something that we want to do that depth first search on. The third part is actually doing that depth first search, which has a return condition. So you always need that return condition. A common return condition is we have hit the boundary. So in here, the boundary is the left, the right, the up, the down. Or it's water, that's a boundary, literally, of the island. And as visited, this is the condition that helps us not backtrack to what we have already visited. Then we need the condition to mark the nodes that we already hit. So V hits the nodes that we already hit. And finally, we have the recursion condition, the most important part, and it sets the rules for how we can traverse those nodes. Here it's a grid. So essentially each node has 4 edges. It can connect to 4 other nodes, a maximum of 4 other nodes. We might also get some graphs where there's only 2 nodes, so or up to 2 nodes. That's a binary tree, and it has the parent. And finally, we could have unlimited amounts of children, and basically we just do a for loop through those children instead of defining all these directions. Yeah, that is my explanation. Let me know what you think.